How does agriculture affect greenhouse gas emissions? Have you ever wondered how farming practices impact our planet, especially in the polar regions? Agriculture plays a significant role in greenhouse gas emissions, and understanding this connection is essential. Let's break it down. Agriculture contributes to greenhouse gas emissions through various processes. The main gases released include methane, nitrous oxide, and carbon dioxide. These gases trap heat in the atmosphere, leading to global warming. This effect is particularly pronounced in sensitive areas like the polar regions. In polar regions, agriculture is still developing due to warming temperatures. As these areas become more suitable for farming, the associated greenhouse gas emissions increase, creating a feedback loop. One major contributor is methane, a potent greenhouse gas. It primarily comes from livestock digestion and manure management. In the polar regions, thawing permafrost and melting glaciers also releases methane that has been trapped underground. When agricultural activities disturb soils or increase organic waste, they can worsen these emissions. Methane is much more effective at warming the atmosphere than carbon dioxide over a short time, making its releases a significant concern for climate change in the Arctic. Another important gas is nitrous oxide, which is emitted from fertilized soils and manure. This gas has a high global warming potential and can linger in the atmosphere for many years. In polar agriculture, using fertilizers on marginal soils can lead to increased nitrous oxide emissions, especially as thawing permafrost releases nitrogen compounds that microbes convert into nitrous oxide. Carbon dioxide emissions are also a factor. Agricultural activities can both releases and absorb carbon dioxide. Soil disturbance, machinery use, and the breakdown of organic matter all contribute to carbon dioxide emissions. However, vegetation in agricultural areas can absorb carbon dioxide through photosynthesis, acting as a carbon sink. In the Arctic, studies indicate that during the summer, some soils and vegetation absorb more carbon dioxide than they emit. But warming soils and permafrost thaw can release stored carbon back into the atmosphere, intensifying climate change. Agriculture also alters soil and vegetation, impacting natural greenhouse gas flows. For instance, better soil management and using local crops can reduce emissions by enhancing carbon absorption and minimizing fertilizer use. However, disrupting permafrost or natural wetlands for farming can release stored greenhouse gases. Energy use in agriculture is another aspect to consider. Local farming in polar regions can lower greenhouse gas emissions by reducing the need to import food, which involves transportation emissions. Growing food locally typically uses less energy than importing vegetables, especially during winter, thus reducing the overall carbon footprint. Lastly, agricultural expansion in the Arctic can accelerate permafrost thaw and greenhouse gas releases. This, in turn, increases warming and affects agricultural viability. This feedback loop is a significant concern for the polar environment, where even small increases in greenhouse gas emissions can have amplified effects. In summary, agriculture affects greenhouse gas emissions in polar regions through methane and nitrous oxide from livestock and fertilizers, influencing carbon dioxide levels through soil and vegetation changes, and altering energy use patterns related to food production and transport. While local agriculture can help reduce emissions by cutting down imports, it must be managed carefully to avoid disturbing permafrost and natural carbon sinks, which are vital for controlling greenhouse gas levels in these delicate environments.